Alright, now we will continue with our last lesson. So I will overview about what I talked about, the node ID and address. So here, as I told you, we have a unified object model in which we have variable, methods and events. So for example, we have an object 1 which has some variables, methods and events. Now what is a variable? Variables are basically the data which you read, write, and the data which has a notification when the data changes. That comes in the variable. The methods are basically OPC commands. For example, the method is, it can be if you're reading the data, or if you write the data, or if you subscribe to the data. We will study that when we do some programming with OPC UA. So these are different methods to have a communication between server and client. And some event in which you need some notification in case of, for example, system errors. So an object consists of these three elements, okay? Variable, methods and events. So there can be more objects with these events, and they can also have a relation with each other. And when we come to a node model, we have attributes and we have reference. Now for example, if you see this window of my client, now every node, like for example this counter, has an attribute which defines the property of this node, and it also defines the reference, which means the connection of this node with another node. For example, I open this variable 1, okay, and I go to inverse and I refresh. So this says that variable 1 is connected by a test, which is this one, and if I click this one, this is connected to a simulation, which is this one. And when I click this one, it is organized by an object, which is this one. And this is organized by a root. So reference is nothing but a linkage of this node with another nodes. And attributes defines the property of this node. So this node has these components, attribute and reference, which defines the nature of this node. And it says every node has a node ID, which is always composed of 3 elements, which we talked about already. So we have a namespace index, which is signified by this. You have identifier, which can be here, it can be string, or it can be integer. We will see that in the next slide. And the identifier itself. What is the identifier here? So 3 things which every node has. So for example, we see NS2, S equivalent to my temperature. In this case, NS is a namespace, index is 2, S is my string, which is a string identifier, and identifier is my computer. Okay. Now here, if you see just I equivalent to 2045, it means it has no namespace index, so by default it's 0. And here it's a numeric identifier. This is defined by a number, and I is for integer. So for example, if we have namespace identifier as G, it defines as global unique identifier. It's a very unique identifier. Now why unique? Sometimes you may have 2 identifiers which are equivalent. In case of integer and in case of string, 2 identifiers can be same. But if you have GUID, this identifier cannot be same. It's a unique one. I don't have an example to show you where we can use it, but I hope if I have one, I will post a video about it. And now there's another kind of identifier which is called opaque byte string identifier. Unfortunately, I've never used it again. I've never encountered some applications where I need to use it. So mostly we will talk about string and integer identifier, and I will show you the example on both of these. Now, as I told you in the beginning, we will talk about OPC UA related to PLC, because most of my courses are related to PLC, and in most of the examples I'm going to talk about PLC, and PLC is the most widely used device in the industry, in the factory. So we'll talk more about how to fetch the data from PLC server. So when the value is coming from a PLC, it has this kind of identifier. So N is 3, like I told you, it's a namespace dynamically generated. S is a string identifier type, and this is the tag. So here if you see OPC read write, this is a 1 dB, value 1, this is the tag. This is a value 1, this is a variable, or you can say this is a tag. And the data type, which is very important, as I told you, it's Boolean. So this is one of the example how a tag is defined if it is coming from a PLC. Okay, we will do a lot of examples on this in our upcoming lessons. Okay, so let's see the first example, OPC UA in the PLC. So what we're going to see in this example, we have an OPC UA server inside the PLC. Now, how this is possible? This is a Siemens PLC, which I'm using in this example, and this is S7-1200. If you have this PLC, you must note that Siemens has a new firmware. Firmware means the operating system of your PLC. So you can download a new firmware, which I think it's 4.4. And once you do that, your PLC will have an OPC UA server inside. The same PLC which didn't have before. As I told you, OPC is just a set of codes. Now the new firmware, it supports OPC UA. So download this firmware. It is available on the internet, on the Siemens website. Just download it. Now another thing is, if you really want to use this firmware, it only supports TIA Portal. Wait a second. I take another pointer. It will only happen if you have TIA. Wait, I should not write here. I have some some text here. It is only possible via TIA v16. If you have this version of your software, then only you can download it in your PLC. That's one constraint. It cannot support v13 or 14. So let's say we have a PLC, and I'm going to show you some data coming to this PLC, some sensor or actuator simulation. And then I will show you how to link this PLC to an OPC UA client, which is installed in my computer. So this is my computer, that's my PLC. And then you have an OPC UA client, which can be Node-RED. As our course is focused on Node-RED, so we will study how Node-RED can be working as a client. This can also be on a PLC, on a PC, and Node-RED can also be on a Raspberry Pi. So client can be on in a computer or in a Raspberry Pi. And then, okay, I'll come to that later. So let's see this example first. OPC UA server in the PLC. So I have this data, factory automation data coming from here. And my PLC is here. So PLC has some values in this DB. And let me just bring it back. So let's say we have this example in which there are boxes coming on the conveyor, and this pick and place arm just pick the boxes and place it on this conveyor. Let's imagine we have this situation. And here I have a tank in which there will be some filling and draining application. So now the information from the factory I/O is going to the PLC. We know that a lot of you have done this factory I/O connectivity with your PLC. So PLC is talking to the software via S7 connection. I'm not talking about OPC UA yet. So PLC, S7 connections, talking to factory I/O. Okay. And if you see, these values are getting updated here. This is the feedback of position of your robotic arm, or you can say pick and place gantry. So the way it moves, it reflects here. Okay. Now if I want to read all these values in my OPC UA client, there are some steps I have to follow. But in this video, I'm just showing you the overview, and then I will show you in detail how this is done. So first I will show you the client. So that's my client. And this is my server, which was from simulation. I don't need it. So I need a server which is on my PLC. Okay, so this is my client. What I'm going to do is I will add a server. Now, how to add the server? To add the server, if you remember, we need three things. We need the endpoint URL. So in this case, if you see your PLC, and as I told you, PLC has its own OPC UA server inside. So I will go to my configuration, and I'm going to show you how this server can be activated. So I will pause this video. So when you go to the property of your PLC, go to the OPC UA here, okay? And if you drag down, you will see activate OPC UA server. So you have to make sure this is ticked. And once you tick it, you will see an address coming automatically. So as I told you before, in case of PLC, in case of simulation, it was RV home, but in case of PLC, this is the IP address of my PLC. And this is the port address of my PLC, 4840, not of my PC now. So I just have to copy this and go to my client, click on add server, put this value here and click OK. And this is already connected multiple times, so I will see it here. And then I open this one and I will see Siemens, that this value is coming from the server. And I will open it again and I will use none as a security. And now you can see here your server is added. And the server has information which is coming here. So I will remove this simulated information before. And here you can see I have a server interface. And the server interface, I have an OPC, and here I have some tags. Now this OPC, what is this OPC? This is my tag. This is the name of my block, OPC, okay? This is the block. Now how this block is coming to the client? So in PLC, the first step was to activate the server, okay? Now let's go down. And here is the port address, which will be by default. And let's understand some properties. It says maximum session timeout, 30 seconds. It means it is a time limit. If there is a no connection, it will keep waiting and try to connect. So for 30 seconds, if there is no connection, it will make an error, okay? Maximum number of OPC UA session, it's 5. It means at the same time, this PLC can only accept 5 connections. So 5 clients can interact. If there are more than 5, it will reject. So this is not a big number, and because it's a S7-1200, it has a limited option. If you have S7-1500, sometimes you have 32 or 48 connections, okay? Another interesting thing is, which is very important, minimum sampling interval. It says it's 100 milliseconds. Now what is that? Sampling interval means every 100 millisecond, the OPC UA server, which is inside the PLC, is going to read the tags, okay? So PLC has some tags in a DB, and PLC have, you can see here, a scan time of 3 milliseconds at the moment, 1 millisecond. So every 1 millisecond, the values are changing, or values are updating. But the server will only read these values every 100 millisecond. And if I go here, I might find, wait, let me see what is the minimum time. I'll go offline. So here I can have minimum 100 millisecond or maximum 10 seconds. Okay, so I choose the minimum value. So every 100 millisecond, the server requests the PLC to give me the values. Okay, this is very important. If you have application which needs faster response, this server may not be the best. Maybe there are better servers in a better PLC, so you need to make sure about your application if this delay is enough or not. This is very important. Another is minimum publishing time. Okay, so this 100 millisecond was to read from its own PLC, and 200 millisecond, this is the minimum, so minimum is 200, is the time which it needs to publish to the client. So in the end, the client is getting in 200 milliseconds. So if I have to explain you in a presentation about these two times. So this OPC UA server, which is inside the PLC, full screen. So this server is getting the value from here every 100 millisecond. So screen pointer, different color. Oh, I took the same color. Whoa. So this, or maybe you can say from here. So every 100 millisecond, okay, not exactly from here, but this is just to explain you. So this OPC UA server, which is already inside a PLC, so it is reading from the PLC every 100 millisecond. Okay, if the value is changing in 1 millisecond, it will lose the value which changed in 99 milliseconds, but it will only take from 100 milliseconds. This is called sampling. So at every 100 millisecond, PLC takes the samples of the value. All right. But to publish this value to the client, it needs 200 milliseconds. So in the end, client gets update value every 200 milliseconds. This is the limitation of S7-1200. Minimum is 200 milliseconds. So this was the setting here in TIA portal. And let's go down. Then you have a server certificate. So maybe if it's blank for you, you can define it from here and double click here. So it will automatically generate a PLC certificate. And this is a certificate which goes to OPC UA client. So if I show you here, like you saw for the simulation, PLC also sends a certificate. And if I show you in manage certificates, that's the certificate lying here from the PLC, from the Siemens. And it says it's valid up to 28th April 2037. So if the certificate expires, you can also renew it. Okay. So for every OPC connection, you have a certificate. For example, this was for PLC. This was for simulation server, which we did process. And the third one is from Vintech IoT device, which I'll talk about later. So client keeps the certificate in its directory. Similarly, server also do that. Okay, now when you go down, you will see the type of security you want. So you can have no security, or you can mention some security, sign and encrypt. Once you define it, you can also define the trusted clients. So you can put a list of the clients here. For example, when the client talks to the PLC for the first time, you have to trust the certificate in the PLC if you enable all the securities. If you don't have security, this option will not be valid. But most of the time, clients and the server has to put the certificate in their trusted list. Like I trusted the certificate of these two, and the client put the list here. These are the trusted certificate. You can see trusted, issue, and issuers. Similarly, trusted certificate list is also in the server. Okay. And comes user authentication. Here you can mention enable guest or enable user ID and password. I have enable guest, so in this case, when I connect from my client to server, it didn't ask for ID and password. If I disable it, it will ask for ID and password, which you can define in the PLC as admin, and here it's password. So every time any client tries to connect to a PLC, he needs to enter the ID and password. This makes the connection secure. Okay. All right, and these were the different settings you need to put in the server. Besides that, if you go to the runtime license here in OPC UA, you have to mention here basic. If you put no license, you can't do the connection. You have to make sure this is linked to the basic. So these were the settings you need to do in PLC S7-1200 to enable OPC UA server. Okay, and in the client side, now I will show you this OPC. Okay, one more thing. Once you do these settings in S7-1200, you go to here OPC UA Communication. And if you open server interface, you have to click add new server interface, and then you have a new server interface like this. And here I have added the DB which I want to push to the server. So it's up to me which information I want to put in the server. So I took this DB from here and I just dragged it here. So this is already here. And once I drag it here, you can see this DB is coming here. So this DB is now in the OPC UA server, and then I download this whole logic into my PLC. So maybe in the next exercise, I will show you a small example doing all the steps by myself, how to put the DB into this OPC UA server. And one more thing, once you are pushing this DB, you have to make sure the property of this DB. So this DB, right click and go to properties. And you have to make sure this is having attributes of optimized block access, and this should be ticked. Data block accessible from OPC UA. These two options you have to make sure it's ticked, and then you download this logic in your PLC so the OPC UA server knows which values he needs to read from the PLC. And these are the values it's reading. This just OPC UA tags. So in this server, you only see these three. In the client, sorry. Conveyor, pick and place, and the tank. It do not read the IOs. It doesn't know what's the status of inputs, what's the status of outputs, because I haven't mentioned that in my server. If I want, that server should also tell to the client about the status of IOs. So I can go to my PLC tags and I can take the tags from my PLC tags, for example, these IOs, and I can push it to my server, then it has more information. It's totally up to me which information I want to open up to the clients. All right. So now I can show you here the same information which is going to PLC. So I will start my process again. So you can see this information is coming in my DB. Go online. Here you can see some information changing, pick and place, and I can open my client. So this is coming in pick and place access. Pick and place access, and I go to I position, Y position, and Z position. And you can see these values are here, which are reflecting from here. And this will have a delay of 200 millisecond for sure. As I told you, this is a limitation of my PLC. So you can use all this information in your client. Box detected is false or true. For example, box detected must be when the box is here. You can see this is true. Or maybe it's something else. I'm not sure about the tags. Wait, let me see. I'm not sure about this sensor. But anyways, you can see the information of this arm movement here. And parallelly, now I told you also about you can change the process. So if I open this conveyor and I have a start and a stop. So start, stop are false. So if I click on stop, I have this box here and I click this one. If I click on stop, my conveyor will not move anymore. So let's see that if my programming is correct, conveyor will not start again. So from this software, I control my PLC. So this is my client. It is controlling the server values. And I make this false again. And we'll start the conveyor from here. So this is started. This is a pulse command. Okay, let's see another example. So I have this tank here now. And here in the tank, nothing is happening. So let's bring it a little bit smaller here. And you can also see the tank here. So I will try to organize everything like this. And that's my client. So tank, this is the input, flow meter, the level, draining, and filling. So let me just delete these one. So flow, there is no flow, there is nothing happening in the tank. There is no level is 0, no liquid in that. Draining, this is the output. So I can put the value. Let's do the filling first. I put 4 and enter. So when I do 4, you can see that the fill valve is open by 40%. And that's the discharge valve. And let's see the tank level as well. So tank level is rising, you can see here. And you can see the tank level here as well. So my client is reading the information. And my client is also able to write the information. So I put 8, so this will be like 80% filling the tank. And if I put drain 4, 40% is draining. And this is possible because this OPC UA client is writing to the OPC UA server in the PLC. And PLC is further linked to the factory I/O. Here I'm just showing you the software simulation example. I'm just talking about the simulation in the factory I/O. But you understand, if the value is going from this client to the PLC, you can also read and write the value to your real actuator because that's a DB. You can just move the value to your I/O tags. So the point of understanding, the idea of understanding here is how you're linking your factory I/O or the real data to your OPC UA client via OPC UA server. Okay. Now you'll be saying, oh, I don't have OPC UA server in my PLC. What should I do? How should I learn? Don't worry about that. I have some next videos in which I talk about what to do if your PLC has no OPC UA server. This example was only in the case if your PLC has a server inside of it. Okay, and once the values are inside the server, you can also display these values, I'll come to that, in a dashboard in the Node-RED. Now the question is how the values are coming to the Node-RED, because so far I just talked about client, which has no programming inside. It's just drag and drop and you see the values, you can control the values, but you don't want that. You need some automatic operations. That's the point of this course. So we will understand how to make some nodes in which we can read the value in Node-RED and further displaying this value in the dashboard. All right, so we can stop the value not from the UA expert by a click of a button or push button or a slider. We can do that. And then we will see, okay, this is Siemens PLC and this is PLC Next. I forgot to mention here. And I have made some web series on PLC Next and OPC UA Server, which you can find in lesson 10 and 12, 10, 11, and 12. This is on YouTube, and I will put the link in the next lectures or the subtitles in the description, I mean. And I've already explained in detail how this OPC UA Server worked with PLC Next, and this is must for you because in this case, I'm using real world data. I'm using the buttons of my trainer and the potentiometer. So this is a real world data, but the fundamentals are same as I explained you in Siemens PLC and OPC UA Server, the same fundamentals we have in PLC Next, but the difference is, just for your information, I'm reading a real world data, which most of you are interested to see. And in this case also you can, I have shown that how to do it with OPC UA Client, and I've also shown how to do it with OPC UA Client. And further I have explained how to do a dashboard. But in this course, we will understand how to bring the values to client and how to make a dashboard. This will be a lesson in this course. All right. So this was about OPC UA Server, which was inside the PLC. Okay, so let's stop this video here and I'll see you in the next video about the next case.